Hello guys, how are you? I hope you are doing well. Um, so we are back again to prove by induction, this time this expression, which is 1 plus 2 raised to the power 2 plus 2 raised to the power 2 plus 4 raised to the power 2 plus dot 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 plus n raised to the power 2 is equal to 1 over 6 times n plus 1 times 2n plus 1. So to better understand this expression, we can rewrite it this way in the form of the sum of n squared when n go from 1 to p being the last term. Yeah. So as you know right now, because you are kind of expert right now when it comes to proving by induction, we have 3 steps. The step 1 is to prove that the expression or the formula is true for the first values. What you can take as first value, what I've take here is 1. So p of 1 here. Maybe in this way you will not understand it, but as you might have noticed, if you see it in this way, what change here is n which varies. So p of 1, because the expression is p of n, like the main expression, p of 1 simply means that n this time is equal to 1. So when n is equal to 1 here, we have 1 squared, which is simply 1. So p of 1 is simply this first value, which is 1. So p of 1 is 1, and if we plug, sorry, let's do that. If we plug that, I'm sorry. If we plug 1 in the formula, we are supposed to, if we plug the 1 here in the formula, in this formula, we are supposed to get also 1 to verify that what we are doing is true. I'm sorry guys, I'm having some trouble manipulate this. So let us plug this in the formula. So p of 1 is also equal p of 1 plug in the formula should be equal to 1 over 6 times 1 times 1 plus 1 times 2 times 1 plus 1. Yeah. So let us take this. Don't mind about what is beyond, because I've done a first video about this, but it took so much time, so I had the idea to redo it and try to reduce the time. So 1 plus 1 is 2, yeah? So 1 over 6 times 1 is still 1 over 6. So then we have 1 over 6 times 2, which is 2 over 6. 2 over 6 is 1 over 3, yeah, by simplification. 2 times 1 is 2, plus 1 is 3. So here we add 1 over 3, yeah? So we have 1 over 3 times 3, which will be equal to 1. So because this is equal to 1, meaning because by using the formula we have the same answer that when we verify the terms, then the p of 1 is verified. So as you know, the step 2 is simply to assume that Pn is true. So that is what I've done here. The step 2 assume that Pn is true, and the step 3 we shall prove that Pn plus 1 is true. So there is we must pass by 2 ways to do that. The first way is to go from Pn to Pn plus 1. And then the second way is to apply the formula directly to Pn plus 1. If the two answers are the same, then we have proved that Pn plus 1 is true. So let's go for our first way. Is from Pn we should go to Pn plus 1. So Pn is here and it stops here. So to go to Pn plus 1, what we should add to the expression is n plus 1 raised to the power 2, yeah, because Pn stops at n, so what comes after must be n plus 1, yeah. So that also means for the other part that we should have the first part of Pn, so the formula not change, 1 over 6 times n plus 1 times 2n plus 1, and then the term that we added. I prefer to split that here, yeah, but basically n plus 1 times n plus 1 is simply n plus 1 squared, so basically it's the same thing. So because the reason why I've split it here is to see more easily that we can put n plus 1 in factor. N plus 1 can be put in factor because we have n plus 1 in this side, and we also have n plus 1 on this side, so we can put n plus 1 in factor. If we put n plus 1 in factor, what will remain here is 1 over 6, which is here. This n will remain, and this 2n plus 1 will remain. On the other side, what will remain will be just 1n plus 1, yeah, because the other one is in factor here. So once we know that, what we will do here is try to factorize 1 over 6. If you try to factorize 1 over 6, it's kind of easy for the first term because 1 over 6 is already a factor of the first term. And then we should do it too for the second term by multiplying every term by 6 and divide by 6, the same thing. And what I've done here in this second line is develop here, multiply the n with this factor. So n multiplied by 2n, it gives 2n raised to the power 2, and multiplied by 1, it gives 1. So as I said, I've transformed n plus 1 by 6n over 6 plus 6 over 6, so that I can put 1 over 6 in factor. So after putting 1 over 6 in factor, what we have here is 2n raised to the power 2 plus n, yeah, this first term, and then the remaining, here we don't have the denominator anymore because we have put 1 over 6 in factor, so the remaining is 6n plus 6. So after that, the things become simple. We can add this n plus this 6n, which will give us 7n plus 6. So for the first part, let's say, of the third step is done, we can remain with this expression. And then the second part will be to apply the formula to Pn plus 1 directly. So Pn plus 1 is here. If you apply the formula, applying the formula to Pn plus 1 simply means that wherever there is n in the formula is this part. Wherever there is n in the formula, we'll just put n plus 1 at instead of n. So 1 over 6 instead of n here it's becoming n plus 1, and here instead of n plus 1 it's becoming n plus 1 plus 1. So here instead of 2n it's becoming 2 factorized by n plus 1 and n plus 1. So after developing everything, we have already, as you can see, 1 over 6 in factor and n plus 1 in factor here. So what we will do here is simply develop this expression, and then after developing, you have seen yourself that the two expressions are exactly the same. N plus 1 times 1 over 6 times 2 raised to the power 2 plus 7 6 plus 6. Conclusion.